Myself Pandiyan, Associate Professor in AAA Department, KPI Institute of Engineering and Technology. In this lecture, I am going to discuss about the control system questions asked in the GATE 2025 in Electrical and Electronics Engineering Department. Consider the state space model x dot of t is equal to x of t plus b u of t and y of t is equal to c into x of t, where x of t, r of t and y of t are the state input and output matrix respectively. The matrices A, B, C are given below. A is equal to 0, 1, minus 2, minus 3 and B is equal to 0, 1, C is equal to 1, 0. The sum of the magnitude of the poles is, this is the question they have asked. They told you to find out the sum of the magnitude of the poles. Okay, so from this question we can say that the poles of the system's transfer function is equal to eigenvalues of the system state matrix. Okay, the state matrix is given by, that is nothing but A is equal to 0, 1, minus 2 and minus 3. So for that we have to find out the eigenvalues. The eigenvalues can be found out through the characteristic equation. The characteristic equation formula is equal to Si minus A equal to 0. So S into I is nothing but an identity matrix. We have A matrix in the 2 cross 2 matrix. Hence, we have used 2 cross 2 identity matrix minus A stat matrix. We have written by 0, 1, minus 2 and minus 3. Is equal to 0. Then we multiply S in the identity matrix. We will get like this: S 0, 0 S minus 0, 1, minus 2, minus 3. Then we are subtracting these two values, we will get S minus 1, G2, and then S plus 3. This is the question, that is the characteristic equation is formed in this equation. Then we have to find out the determinant. Determinant, how will you find out the determinant? S into S plus 3 plus 2 into minus 1. So minus of minus plus, so we will get plus 2 equal to 0. Then we are multiplying, we will get s squared plus 3s plus 2 is equal to 0. So this is the quadratic equation. We are factorizing this quadratic equation. We will get s plus 2 and then s plus 1 equal to 0. So we will get the factors are s equal to minus 2 and minus 1. So already we have said that the poles of the system's transfer function is equal to eigenvalues of the system's state matrix. So this is the value we have. So s equal to minus 2 as well as minus 1. So they told you to find out sum of the magnitude of the poles. So sum of the magnitude of the poles is equal to, we have to make it a magnitude. So for that we have to go for modulus of minus 1, modulus of minus 2. We have to add it. So it's equivalent to 3. So the answer is 3. The op-amp in the following circuit are ideal. The voltage gain of the circuit is, so from this question we have two operation amplifiers are connected as shown in figure. Here we have to find out the voltage gain. What is voltage gain? Voltage gain is nothing but output voltage divided by input voltage. That is the gain of the amplifier. So I've redrawn this diagram here. Okay. In this diagram, they have not mentioned any. They have mentioned V in. That's all. They have not mentioned about. We have two terminals here. First operation amplifier, we have one terminal. Another operation amplifier, we have another terminal for V in input. So for that purpose, I have taken V in is equal to V2 minus V1. So here V1 is in the first operation amplifier non-inverting terminal input, as well as V2 is nothing but second operation amplifier non-inverting input. Okay, so here I have taken V1 as well as V2 in this problem. So by virtual ground concept, we can write it as that this potential is equal to V1. Similarly, here also we can write V2 by virtual ground concept. Whatever the input is given to the non-inverting terminal is equivalent to the inverting terminal input. So that's why we have taken V1 as well as here V2. Okay, now we are applying a KCL for the operation amplifier 1 node V1. Okay, so what is the formula for Kirchhoff's current law? Kirchhoff's current law is nothing but incoming current is equal to outgoing current. So here the incoming current we are writing as 0 minus V1 divided by 10K is equal to 0 V1 minus Vx divided by 10K. So we are writing the we have written the KCL equation for the node V1. So we are simplifying that. For simplifying 10K as well as 10K is cancelled each other. Then we will get minus V1 is equal to V1 minus Vx. Next what I have done, Vx is equal to V1 plus V2. Rearranging the equation, we will get Vx is equal to 2V1. Next, I am applying Kirchhoff's current law for the operation amplifier 2 that that to node V2. So here also I have taken the incoming current is I3, the outgoing current is equal to I4. So Kirchhoff's current law, sum of the incoming current is equal to sum of the outgoing current. Here we have only one current, that is the incoming current is I3, the outgoing current is I4. So we have written like this. So here Vx is equal so incoming current I3 is equal to Vx minus V2 divided by 10K is equal to V2 minus V out divided by 10K. So we are 10K is common for both the cases. So we have we can cancel each other. So we rearrange this equation. We will get uh, here I have mentioned Vx is equal to 2V1 minus V2 equal to V2 minus V out. So V out is equal to V2 plus V2 minus 2V1. So we can write it as V2 plus V2, 2V2 minus 2V1. We can take 2 as a common. So 2 into V2 minus V1. So V out in the left hand side, 2 V2 V2 into V2 minus V1 is in the left hand side. So we will rearrange it V out divided by V2 minus V1 because they told us to find out the gain of the operation amplifier. So gain of the operation amplifier. Hence V out divided by V2 minus V1 is nothing but V in. So V out divided by V in is equal to 2. Hence the answer is 2. Question is a Boolean function is given as f is equal to u bar plus v bar plus w bar plus x bar into u bar plus w bar plus w bar plus x into u bar plus v plus w bar plus x bar into u bar plus v plus w bar plus x. The simplified form of this function is represented by the following options. Okay. So we have to simplify the given Boolean function. The Boolean function given here is a product of sum term, that is we call it as the sum term is called as max term. In max term, we will consider a complemented form of any variable is equal to 1. If I am considering a as a variable, the complemented or complement form of a is equal to 1. If it is uncomplemented form of variable is considered as 0. Hence, this above function may be written like this. So u bar is written by 1, v bar is written by 1, and then w bar is written by 1, as well as x bar is written by 1. Similarly, for another term, we can write it as 1, 1, 1, 0. Next term, 1, 0, 1, 1. So next term 1, 0, 1, 1. Okay, hope you understood. Next, we are converting this hexadecimal format, binary format into decimal format. So binary format is converted into decimal format. The decimal format we can convert it using the 8421 code. So here double one and double one we can write it as 15. Double one, 10 we written as 14. Similarly, 1011 is written by 11, and then 1010 10. So we can write the decimal version of the binary value as 15, 14, and 11 and 10. Here, this is a four variable function, so we have to use four variable Karnaugh map to reduce the function. Okay, we have four variables u, v, w, and x. So uv will be in the side, and then wx will be in this side. So Karnaugh map, four variable Karnaugh map is constructed. That it is a product of some term, so we have to give 0 for the each terms. So 15 is be considered as 0, and then 14 value is considered as 0, then 11 considers 0, as well as 10 is considered as 0. Then we have to map here 4 zeros, so we can form a quad form. If you form a quad, so we in this corner map, double one as well as 10 is related to u v variable. So here only u variables are common, so we will take it as u. It is in one, so uncomplemented form we have to use u bar plus this side wx variable side, here also common term 1 1, and then 1 0, the common term is 1, so that 1 is represented, it's equivalent to w variable, that w is represented by 1, so complemented form, so u bar plus w bar. So the given variable is in u bar, we have to give it to u bar plus w bar. So this is nothing but u we have to give, not gate will give u bar, then w will be given here, the not gate will give w bar. Then we have to or it the two functions, so we will use or gate, so produce the function f is equal to u bar plus w bar using this arrangement, this logic diagram. So the answer is E. Thank you.